Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled, NASA indicates that Planet X system is affecting the Sun. And I have written previously in article 88 something that challenged NASA to prove that Planet X does not exist, and that was after the NASA spokesman Dr. David Morrison stated categorically that Planet X does not exist. So I challenged NASA to prove that it indeed does not exist, and I suggested that they stop using that. In order to do that, they should stop using cutoff lines in the SDO images, stop removing data, and provide the public with access to their SDO live feed in real time. Now, in response, NASA has continue to do what they have been doing for many years, and that use cutoff lines by covering up part of the Sun in these SDO images, obviously going to this extra effort to cover up whatever object was there to be seen. And we can see in this image that the Sun is clearly going dark, because we can see that the interface between the darkness and the part of the Sun that's emitting light is not a smooth, straight line. What we have is a jagged interface here between light and darkness. This would be somewhat like what we'd see at the edge of a coronal hole. However, this is not a coronal hole. If we compare what is over here in the Sun and what is there just a few minutes before. This image is from 2045. This one is from 2028. There's clearly no coronal hole there to cause any jagged edge. So this shows that the Sun is going dark. This region of the Sun has gone dark. So the Sun is going partially dark as well as a result of interacting with the objects that have come to the Sun, this Planet X system of dead stars or stellar cores that are affecting the Sun and causing it to get progressively dark, to get progressively weakened, and therefore basically the Sun is dying as a result of this withdrawal on its energy. And you can see that this also happens in other wavelengths. We see the 304 wavelength image here and the 335 image. The same thing occurs. We can see this jagged interface here, thus indicating that the Sun has gone dark on this side, the Sun's gone dark on that side. You can see little portions of light still being emitted after beyond this edge where darkness appears. So this is clearly a portion of the Sun that has gone dark in several wavelengths, and we can see the same here in several other wavelengths. We can also see that because this line is larger here, the length of the line separating the light from the darkness is much longer here than it is there. You see that the cutoff lines seem to be in the same position, but yet this line is longer, and this would mean that a larger portion of the Sun on this side is darker than the portion that is darker over here. So the same thing happens here, and even this one even seems to be even shorter than this one. So this suggests that the Sun is going dark at different rates in the different wavelengths. So the Sun's losing light emission as a result of the stellar cores interacting with it at different rates for the different wavelengths. And then we see in this one that clearly this is the visible light image. We can see that the Sun is therefore also losing light emission in visible light, and in fact it's more affected in visible light, because if we compare the amount of light emission that it's lost in visible light with what it's lost in the 193, which is an ultraviolet wavelength, you can see that it's lost more in visible light. These are about at the same time. This is 21.0, this is 21:59:53. So only a few seconds difference. You can see that the Sun's gone dark here, it's gone dark in the same position. You can actually see that this whole portion here of the sun has gone dark. And we also see some kind of interaction going on here. The sun seems to be connecting to an object here. There are these lines here. Some of these lines are in the form of plasma loops. These are never seen in these visible light images. Also almost looks like there are two images on top of each other or superimposed on each other, as if the sun was moving at the time that the image was taken. And we see that happens in other images as well. You can clearly see the interface here. Now the sun has gone dark in this region, and we can see by comparing the sun with what it looked like a few minutes before that there is no coronal hole there that could possibly have caused this to happen. So the sun's clearly going dark. Now this is an image of the sun from yesterday. This is from April 12th in the 211, where we can most clearly see the corona. You can see how small the corona is getting. The sun did get a permanent coronal hole at the North Pole and another one at the South Pole a few years ago, and it seems to be opening up into a permanent coronal hole at the equator now, and therefore this shows how the sun is progressively getting weaker, how it's losing its corona basically as a result of the stellar cores drawing matter from it. And I've written about that in several articles. And here we see several images where the sun is clearly out of focus, seems to be in motion. And this would in fact be attributed to the satellite being in motion at the same time, except for the fact that the sun is interacting with these stellar cores. This is not as usually seen in images where we don't have cutoff lines. And the fact that these cutoff lines appear when the sun seems to be in motion suggests that it is the sun itself that is in motion and not the satellite. We can also see that the lines appear in different positions. You can see a line here covering up part of the sun. The timestamp on both images is only 2 seconds apart. And this shows that these cutoff lines are placed individually with each image, so it must take a lot of effort. And we can also see that part of the sun here is dark, and we don't see anywhere where it seems to have gone dark. Different portions of the sun seems to have gone dark for a small portion there, but clearly a different amount than what we see in this image. So, and the timestamp here is exactly the same. So this image was taken at exactly the same time. We can see here the sun at 2046:13, so 12 seconds later. It's still slightly out of focus in the 193 image that was taken at that time. So possibly indicating that the sun was still in motion. You can see this cutoff line seems to be in a different position to what it was in the other images. Again, and there's no cutoff line appearing at the top. There does seem to be a cutoff line at the bottom here. So cutoff lines are introduced in the different images in different positions according to wherever NASA decides that there is something that they don't want us to see. And yet it's quite obvious that something's happening with the sun. And we can see images here of the actual objects that have appeared in some of these images, and but at this time, these particular objects were not causing the sun to go dark, so no cutoff lines were used. So we can see what they look like, and this is clearly a spherical object with stripes. The stripes are curved. I like this image a lot because it shows what these objects actually look like, and the fact that they have stripes, and the stripes are curved, thus following the curvature of the object, thus indicating we have a three-dimensional object in the sun's corona. We can see the plasma that is attached to the object as the object moves in its trajectory around the sun. So this is clear proof that these objects are there. They are in the sun's corona. They are interacting with the sun, and sometimes some of them actually cause the sun to go dark. It happens during the STO eclipse season, and it happens at these times when the sun goes partially dark, as these images indicate from April 11th. We can see another one of these objects. This is the blue stellar core, and this stellar core was photographed through a telescope by Scott Young. And the sun that we see here is not actually the real sun, because this was taken from the Earth's surface, and there are, of course, simulators that we see instead of the sun from the Earth's surface. So this is actually a simulated light source. It's a sun simulator, and what we see behind it is the stellar core, which seems to be connecting to the sun. Now, these are then the types of objects that NASA keeps saying do not exist, but yet keep proving by their actions that they indeed exist. It must take a lot of work to add cutoff lines to each individual image, which explains why they may only allow the public to see a few of these. These give us a small snapshot of what is happening with the sun, but yet these small snapshots clearly show that what is occurring with the sun, and that is that it actually does go dark. Now, on the other hand, it's hard to believe that NASA could be so bad at hiding the truth. Is it possible that they are in fact showing us the truth on purpose? Is this in fact an effort to hide something much worse, such as the fact that some of these objects have been captured by the Earth and are in the beginning stages of tearing this planet apart? So for more details about that, see article 201, Africa Breaking Up, a preview of what is to come. In conclusion, whilst continuing to say that the Planet X system does not exist, NASA keeps proving that it does exist. Their actions include covering up SDO images, taking the effort to do so with each of the individual images they make available to the public. However, even after being doctored, the images still reveal that the sun is being affected by external bodies. These images clearly show that the sun is going partially dark at different rates for different wavelengths, and that the sun actually moves or jolts in response to the presence of these objects. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.